In this lesson, we're working on graphing in vertex form. And the graphing that we're going to be doing is graphing a quadratic, which we know is called a parabola. All right, so we want to review the vocabulary first. So this is our vertex, which is our highest or lowest point of our parabola. Remember, if it's the lowest point, it is our minimum. If it becomes the highest point, it's our maximum. It's our lowest point if our parabola is opening up. It's our highest point if our parabola is opening down. Remember, where our parabola crosses the y-axis is called the y-intercept. And where our parabola crosses the x-axis is called the x-intercept. From earlier lessons, we also remember that this could be called a root, it could be called a zero, or it could be called a solution. The curve itself is called the parabola. And our axis or line of symmetry is what divides our parabola exactly in half. And remember that the left and the right side exactly match. They are mirror reflections of one another. When we are working with a quadratic in vertex form, we remember that the a value has a special purpose. It helps us to remember whether our parabola opens up or down, and if it's wide or narrow. Up is positive with our leading coefficient. Down has a leading coefficient that's negative. The absolute value of a is greater than 1. The bigger it gets, the more narrow it is. Our absolute value of a, when it's less than 1, makes our parabola wider. The h is our horizontal shift, meaning our shifting left and right. Our vertical shift is our k value, vertical meaning up or down. In vertex form, we know that the vertex is our hk. So if we take a look at our first example graphing in vertex form, remember that our minus sign is part of our formula. So our h value of our vertex is always going to be the opposite of what we see. So the opposite of positive 3 would be negative 3, and we would have our negative 4 as our k value. So when we graph that, we have negative 3, negative 4. Our a value is 2. So if you remember, our parabola then, since this is a 2, is going to open up. And when it opens up, we know that it has a minimum as our vertex. If you remember, when we graph with the parent function. And we are squaring. Our parent function is y equals x squared. So we square each of these values. And then since our a value is 2, we're going to multiply our y column by 2. We are going to cross out that y column because what we have done is we have stretched our parabola. And this 0, 0 I circle, it is our vertex, and it has been shifted to negative 3, negative 4. So from that vertex, we're going to go over 1 unit to the right and up 2, over 2 units and up 8. And we don't have enough room for the 318. We'll draw in our line or axis of symmetry, reflect our points to the other side, And then we can draw in our parabola, making sure to put arrows on each of the ends to show that it's infinite. Our domain is our x values, and because our domain is going infinitely left and right, we know that x is an element of the reals, just like we did with our absolute value functions. And then our range is our y value. Since our lowest y value is at -4 and our parabola is opening up, we're going to have greater than or equal to -4. All right, next example. Our vertex, we know it's the opposite of the h value, so it's going to be at 2, 6. Our a value is -1, which means our parabola is going to open down. And since our parabola opens down, it will be a maximum. Our vertex is at 2, 6. Our parent function, we put in our table 0, 1, 2, 3. We square each of these. And then we multiply our y column by -1. Crossing off the middle, since we have changed those values, and we circle the 0, 0 to remind us that that is our vertex. From our vertex, we're going to go 1 unit to the right and 1 down, and 2 units to the right and 4 down, and 3 units to the right and 9 down. We're going to draw in our axis or line of symmetry, and then we will reflect the other points to the other side of our axis of symmetry. We will draw in our parabola, putting arrows on each end, and reminding ourselves that the domain is infinite for x is an element of the reals, but the range is the y values, which are starting at 6, and this time going down, so y will be less than or equal to 6. In our next example, our vertex is going to be the opposite of our h value, which is 3, and then our k value. Our a, our leading coefficient, is 1/2, which is positive, so it's going up. Since it's going up, our vertex is going to be a minimum. Our vertex is at +3, -2. We'll put in our parent function values. We're going to multiply each of those y values by 1/2. We will cross off the middle column since we have changed that. Circle the 0, 0, which is our vertex. From our vertex, we're going to go over 1 and up 1/2. Then we're going to go over 2 and up 2. We're going to go over 3, up 4.5. We'll draw in our parabola, arrows on both ends. Our domain is always x is an element of the real numbers since we are going infinitely left and right. Our range is going up, so it's going to be greater than or equal to, and our y value of our vertex is at -2. This is going to be wider than the parent function because the absolute value of our a is going to be less than 1. Our a value is 1/2, and that is going to be less than 1, which makes our function wider. If you would take a look at the next examples and finish those for practice.